This video is brought to you by our new sponsor, Watler Water, which has very kindly decided to sponsor my computer science videos. So a big shout out to Watler Water. Okay, so what I'm going to do is introduce you to some basic Boolean laws to begin with. These are going to be kept really simple, and basically it is math in itself, really basic math, and logic gates, you could say as well. So we appreciate that this plus symbol means an OR gate, and whenever we use this, we're dealing with a AND gate, and if we're dealing with this, we're dealing with a NOT gate. Now in math terms, this plus is a plus. Instead of this dot, we're going to use multiply. So if we had a plus 0, that a can change the result of what this x is going to be. So if it was, for example, a 1, this x would be a 1. If, however, the a was a 0, the x would be a 0. Therefore, our first rule is that if we have a plus 0, it would equate to a being the most important factor which could influence the result of this sum. If we had a plus 1, well, we know no matter what a is, a could be 1, is going to be a 1. If a is a 0, and we're talking about an OR gate, it will still be a 1. 1 or 0 would be a 1. Therefore, it doesn't matter what a is, a plus 1 is always going to be a 1. Let's move it forward. So if we're dealing with a and 0, another way we could say is a multiplied by 0, it's always going to be, in this situation, a 0. It doesn't matter what a is, 1 and 0 cannot be a 1 with an AND gate truth table. So if we had a and 1, or multiply 1, the value of this a makes a difference to what this result would be, i.e. what x would be. If a was 0, then this would be a 0. If a was 1, this would be a 1. So because of that, it's going to be a and 1 would be a. We're relying on whatever a is in order to make the difference. We've also got, what happens if we've got a or a? Well, this is going to be the result being a, as in whatever the value of a is will have an impact on the answer. Pretty simple, and that's going to be the same for a and a. Whatever a is will have an impact on our answer. Another rule would be, what happens if we had a or not a? Well, that's always going to be a 1. How do we know that? Well, imagine that a was 1 or not 1, because we're talking about the value a is 1, which is 0. It's going to give us a 1. Let's imagine that actually a was a 0, and we not this 0 becomes a 1. So it's always going to be a 1. So a or not a is always going to give us 1. If we have a and not a, that's always going to give us a 0, because it's the same as saying 1 multiplied by 0. It's always going to be the case. If we had a being 0 and we knotted it here, it'll be a multiplied by 1. If we had the situation that a was 1 and we nested it, it becomes a 0, so it becomes a 0 as a result. Therefore, it's always going to be the case. We then got the rule, what about if we had a not, so double negation. So 2 nots. Well, this is always going to lead to this being a. So if you think about it, if we have 1 and we decide to not it, it's going to give us a 0. So we've done this not, but then we do this not again, it turns it back to 1. So it's always going to leave us with the first original value, i.e. a. So these are the first few rules I would like you to become comfortable with. Yet again, as I said, it's basic math. End of section 1. If you're liking the video, give me a thumbs up. Oops, and subscribe. So this next law is the associative law. And what does that mean? Well, if we've got in brackets A or B or C, it's basically the same as if we did it in this order instead. A or B or C. So it doesn't matter actually by which, doesn't actually make any difference which terms we OR first. So this is term 1 and term 2. We OR these with then term 3, or we could do term 2 with term 3, then with term 1. It makes no difference. So as a circuit, it would look a little bit like this. Let me just change the color. A, B, C. That's a really poor OR gate. In fact, I was drawing the wrong gate there. So that's equivalent of literally if we did it as B, C, that's an OR gate by the way. It's the same. Makes no difference about the order. So the associative law also works the same with AND gates as well. So if we had A and B and C, and I decided to do this, it's the same as doing anything like this. A and brackets B and C. Exactly the same. Makes no difference. Okay, so what I'm going to do is jump to rule number 12. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. We have spoken about these, but I'm going to go back to these later. But in continuation of our sequence, we've got rule number 12, where we're going to use what's called the FOIL method, where it's first, outer, inner, and last. And what we've got is A or B, and you might say, hang on a minute, how do we know it's and? There's no dot. Well, we don't need an actual dot to represent the and. So ANDed with A or C is the same as saying A or B and C. So if we're actually going to do this, I've just made some space down here. If we're going to do our our first, so this is our first, we're going to do A and A, our OR. We're now going to be doing our outer, which is going to be A and C, so this is going to be the outers. Outer, outer. Or our last, which is going to be B and A, so B and A. So we've gone our firsts, our outers, our lasts. So we know from here that we've got A and A and A, which is equal to A. So I'm just going to put an A here. I'm not sure if this has been chopped off, so I'm going to scroll down a bit. Pretty simple so far. Or A and C, or B and A. I want to quickly apologize. I've actually missed off our last, which is B and C actually, so undo that one. So B and C. That's my fault. That's the last. B and C. Our inner was B and A. So let's go through that again very quickly. First, that and that. Our outer is A and the C. Our inner, which is going to be the B and A, and the last, which is going to be the remaining B and C. So going back to this, or B and C. So what can we see in terms of patterns? Well, what we can see is that the first term and the second term have a common term, so we can actually factor it now. So we can factor it out. So what's that going to look like? Well, that's going to look like A bracket 1 or C close bracket, or B and A, or B and C. Okay, so we've factored it out. So now let's examine what's inside this bracket. 1 or C, which is actually the same as, if we look at our rules, so I should be using a mouse for this bit. Here, A or 1 equals 1. Obviously, A could be anything. It could be apple, orange, lemon, or B, C, D, E, F, G, H, I. In this case, it's C, which means it's 1. So what we then have is the following. A and, oops, I need to erase that because it doesn't look neat. There we go. So we've got A and, this is going to be equal to 1 based on our rule from here. Or B and A, or B and C. Okay, so let's look at the first term and the next term. Do we have anything in common? Yes, we do. We've got A and A, so we've got to factor that out again. So we're going to have A, 1, or B, or B and C. So let's have a look. Got nothing really with this A, so let's look at this. We've got 1 or B. We know that that will equal 1, so we're going to do A and B, and then we're going to have or B and C. So what happens next? Okay, I'm hoping you spotted the mistake I've made. This shouldn't be B, it should actually be 1. My fault. Okay, so A and 1, if we go to our rules, should be going to be giving us, if I go right up, A. So it's equal to A or B and C. We can't go any further. So we've got A or B and C, which is basically what we've got here. By simplifying it, that and that, all these steps, created this. Magic. So we've proven that this law is true. Okay, so if we've got our rule for number 10, we've got A or A and B equals to A. So how does that actually work out? Well, let's have a look. Let me just rewrite this out here. A or A and B. So this is similar to what we did for rule number 12, where we actually have a common term. We've got A and A, so we're going to factor it out. So it's going to be A, 1, or B. Let's put a dot here just to remind me. Pretty simple. Now we know that 1 or B is going to be a 1. It's this rule here. So what we've got is A and 1. Can I say that 1 and B would be B? No. 1 and B would be 1. Okay, so we've got A and 1 equals A, because we know the rule A and 1 equals A. So what we've just done is we've simplified this by using this process to prove that it is actually A. This is getting very messy now, but never mind. So what we're going to look at now is another law, which is known as the Distributive Law. And what that tells us is the following. So we've got A and B or C, which is the same as if we did A and B or A and C. So if I did a circuit A, B, C, and we had this going to an AND, and these going to an OR first. That circuit here, if you work out a truth table for it, it's going to be the same as A, B, C. So we've got A and B. We've got also A and C. That's a really bad AND gate connected by an OR gate. Excuse me. And if we did a truth table for this, you would see that actually both results are going to be exactly the same on that truth table. So this is known as the Distributive Law. I would add it down here with our cumulative and associative, but I'm not going to. Let's move forward. So the final law we're going to be dealing with is a law which is actually pretty easy to understand. It's called the Absorptive Law. And that's basically saying A or A and B equals A or A, and A or B equals A. So if I was going to do a circuit for this, let's do A, let's do B. We've got A there, we've also got A going to an OR with B. That's an OR gate, by the way, folks. And let's connect them up by an AND gate. And we did a truth table for this, A, B, Z. 0, 0, 0, 0, 1, 0, 1, 0, 1, 1, 1, 1. What we can work out from this truth table is that when A is 1, The output is always going to be 1. So basically, another way of saying this is, so what you'll notice is that the output is always going to be A, either for this one or this one. So if you can spot the pattern in a more complex expression which we'll face, so if you can spot this pattern, you would know that actually it's going to be A. You can simplify it pretty quickly. So let me give you some simple problems to begin with. So I'm going to give you the expression. No, I'm not, because my pen's not working. Here we go. A or A and B. And what I want you to do is see if you can simplify it. Pause the video, I'm going to give you a solution. Okay, the first thing we can do is look for common terms. We've got a common term here, so let's factorize it. So A, bracket 1, and B. Okay, so that's step 1. Now what can we do? Well, we've got a relationship here where we know that if we've got 1 or something, i.e. B, it will equal 1. So we've got now step 2, put 1 here, and we're going to AND it with A. Step 3, we know that A and 1 equals A, and that is simplified. Let's do another one.